here we're going to look specifically at what it means to perform a permutation. Now, a permutation helps you calculate the number of ways possible that a group of items can be ordered, provided that we're using each item only once. Okay. Now, the important piece to remember about a permutation is permutations are used when order is important. Okay. So, for example, if you're told that you have to create a security code where your first digit must be a number, but your second digit must be an alphabet, and your third digit must be another alphabet, however, you can't have anything repeating, your order is going to be important, and so that's going to come into play. Okay. Now, we have a couple of formulas that you need to pay attention to. First is the formula in general for your permutation. And so when we're talking about permutations in general, we are using the term where you have a little n with a PR. P stands for permutation. And in this case, this is going to be n factorial all over n minus r factorial. Now, what's important to remember about that equation is that your n is going to equal the number of objects that you have, whereas your r is going to equal the number that you choose, okay, or the number chosen. Now, with that, we have a secondary formula, and this secondary formula we use when you have repeated objects. A classic example of repeated objects is if you have, say, a word that has quite a few of the same letter, like, for example, supercalifragilisticexpialidocious. Now, that's a really, really long word, kind of fun to say. But if you were to spell that word out, you would notice that there's quite a few letters that are going to occur, that they occur more than once. So if I wanted to find the number of ways that I could order those letters out of the word supercalifragilisticexpialidocious, I would have to use what's called permutations with repeated objects. So a permutation with a repeated object is essentially going to be n factorial on the top, and then on the bottom is going to be the number that you have in its factorial time for however many of them that you have. Okay. And so in this case, when we're talking about, say, the number, this is going to represent the number of times an object repeats. So, for example, in that word, supercalifragilisticexpialidocious, if I wanted to know, or if I listed all the letters out, in order to figure out my numbers down below, I would say, for example, how many A's did I have? Well, so this, if there was, say, only 2 A's, then it would be 2 factorial. If I had 7 I's, it would be 7 factorial. So you would do that for each individual object, and you would count up how many times they occur. Okay? So those are the two formulas you need to pay attention to. What we're going to do is I'm going to show you a bunch of different examples so you can see how this works. So in the first, we want to evaluate your permutation. So in this case, we have 10. The P stands for permutation 2. So what this is telling me is that n equals 10, r equals 2. So if I plug it into my formula, I would have 10 factorial over 10 minus 2 factorial. So if I were to simplify that down, I know 10 minus 2 is 8, so my bottom is 8 factorial. My top would be 10 times 9 times the 8 factorial. In this case, my 8 factorials would cross out and would leave me with 90 as a result. Now, with like everything, we can always double check ourselves with our scientific calculator. So here again is mine. Again, yours might not be the same as mine, so you're going to want to make sure that you can figure out how these buttons work for your specific calculator. But in mine, if you notice, I have with my factorial, I have NCR, NPR. And when you click that button, what happens is you have to be able to put some information in there first. So n comes first. In this case, my n would be 10, so I would type 10. I would hit my button here. So the first time is factorial. Second time says I'm going to do NCR, but here I want NPR. My R is 2, and hit enter, and it does it for me. So I highly recommend you always do it by hand first, and you use your scientific calculator to double check your work and make sure you're on the right page. So do take a minute and figure out where your probability buttons are. They might be in a menu or which button they're listed on, and then figure out how they work on your calculator. Alright, let's do it again. Here I have 7p4, so my n is 7, my r is 4. If I plug it in, this would be 7 factorial over 7 minus 4 factorial. So in this case, I know 7 minus 4 is 3, so this is going to be 7 times 6 times 5 times 4 times 3 factorial. All over that 3 factorial. I can cross out what is the same, and in this case I end up with 840 as a result. Now one more time so you can see once again how it works. I would start with my 7. I'm going to use my probability button, change it over to NPR. I'm doing 7 NPR 4, hit enter, and we get 840. Now the most common way to see permutations is as word problems, and what you have to be able to do is you have to be able to determine what pieces of information go where. So in other words, you have to be able to determine what is your number of objects versus what is your number being chosen. So in this first one, we have in how many arrangements can be made using 4 letters in the word combine, and then if no letter is to be used more than once. So this right here tells you you're using a standard permutation because nothing is being used more than once. So I want to use 4 letters. So here my n is going to be the number of letters in the word. So you would count them up, 1, 2, 3, 4, 5, 6, 7. So this would be 7. My r is going to be the number chosen, which in this case was 4. So again, just like on the other page, we would set up NPR, so this would be 7PR, and that would give you 7 factorial over 7 minus 4 factorial, which from the example we just did gives you 840. Well, let's look at another one. For a segment of a radio show, a disc jockey can play 7 songs. If there are 13 songs to select from, how many ways can the program, or can he create his program? Okay, so in this case, we would have that your n is going to be your total songs, and that was I have 13 to choose from. My R is going to again be the number chosen, which we're told was 7. So we need to create our permutation. So this is going to be 13p7. So I'm going to have 13 factorial over 13 minus 7 factorial. So in this case, we would end up with 13 factorial over 6 factorial. We could expand that out. 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial all over my 6 factorial. That crosses out my denominator and is going to leave me with 8,648,640 ways. Okay, so that's a lot of ways that we could create a song. Alright, here we have in a race in which 6 automobiles are entered, there are no ties. How many ways can the first 3 finishers come in? So first and foremost, we have that N is going to be the number of cars. In this case it was 6. R is going to be the number of finishers, which in this case is 3. So here we would have 6p3 gives you 6 factorial over 3 factorial, 6 minus 3 factorial, which is 6 factorial over 3 factorial, which we know is going to break down to being 6 times 5 times 4, which is going to give me 120 ways. Alright, last but not least, we have in how many distinct ways can the letters in the word Tallahassee be arranged? Now notice nowhere in this does it say that the letters are not repeated, nor does it actually say that we're choosing any. We want to know how many ways to arrange this. So this is going to be a classic permutation with repeated objects. So because of that, the first thing we want to do is we want to start listing out our letters. So I have a T, I have an A, I have an L, I have an L, so I'm not going to write it again. A, I have an H, A, I have an S, and an E. So here I want to look at how many of each of these letters do I have. So for my T I have 1, for my A I have 1, 2, 3. For my L I have 2, my H has 1, my S has 2, and my E has 2. So what I have here is that I have my N, which counts up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here my N equals 11, which is the total number in my word. So to find my permutation, I'm going to do 11 factorial divided by, and then I'm going to take each of these types and put a factorial underneath it. So I have 1 factorial times 3 factorial times 2 factorial times 1 factorial times a 2 factorial times a 2 factorial. Okay. So now the easiest thing to do is going to be that you want to cancel out the largest denominator. Okay, so here we would be looking at 11 times 10 times 9 times 8 times 7, 6 times 5 times 4 times 3 factorial. And this is going to be all over 1 times 3 factorial times 2 times 1 times 2 times 2. Now the reason why I can just say 2 and 2 is because if you look at 2 factorial, it's 2 times 1, which is the same as 2. Now with this, my 3 factorials will cancel, and then I have 2 times 2, which is 4, times 2, which is 8. So in this case, I'm going to multiply across the top, divide by 8, and you're going to end up with 831,600 ways. Now, I don't know about you, but that is a lot of ways to order the number or the letters out of the word Tallahassee. So if you have any questions, please let me know. Otherwise, you now have 4 really good word application examples of permutations and a couple just straight calculations. Again, all dealing with instances where your order matters. So again, if you have any questions, let me know. Otherwise, I'll see you next time.